Hi guys, this lesson is perpendicular and angle bisectors, and the goal is to use properties of perpendicular bisectors and angle bisectors. The standard is congruence 9 and similarity, right triangles, and trig number 5. What you should learn in this lesson is that there is a special relationship between the points on the perpendicular bisector of a segment and the endpoints of that segment. In the diagram below on the left, line CD, right here, is the perpendicular bisector of line segment AB. A perpendicular line sector means it crosses the line at exactly right angles. So it gives us two right angles, which equals 180, and it cuts the line directly in half, which makes line segment AD congruent to line segment DB. In the drawing on the right, I have line segment CA and line segment CB drawn in, and they complete two triangles. I have triangle CAD and triangle CBD. Now, if you notice, and what you learned in Chapter 4, you should realize that triangle CAD is congruent to triangle CBD. And because the triangles are congruent, we can conclude that line segment CA is congruent to line segment CB, or that we could say CA is equal to CB. Now they say that a point is equidistant from two objects if it is the same distance from the two objects. So points A and point B are equidistant from point C. The perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, like point P, then it is equidistant from the endpoints of the segment, A and B. So when I connect P to A and P to B, I get two congruent lines, or two congruent sides of the triangle. And notice, because they're not touching the right triangle, those two sides are the hypotenuse. Now, another way of saying this is called converse of the perpendicular bisector theorem, which just says if you make a point that is the same distance from two endpoints, then that point, point P, is on the perpendicular bisector, which makes line PM perpendicular to line segment AB. And that cuts line segment AB in half, so I get MA is congruent to MB. Lots of words for something that's really pretty simple. This question asks, what is the measurement of angle BCD? So it really wants to know, what is the measurement of angle C? Well, I notice that I have two right triangles, and these sides are congruent, which makes this side congruent. So all I need to do to find this answer is to take 66 and add it to another 66 for that part right there, and I get 132. So the measurement of angle BCD is 132 degrees. Your first question is to find the measurement of angle TSR. So you want to find the measurement of angle S, because S is the vertex, which is the angle. Next question, if RS and RU are both 58 and TU is 85, what is ST? Well, this line TR is a perpendicular bisector. I know it because it makes two right angles. These two are also the same. So if that is the case, and this point is on the perpendicular bisector, these two sides are congruent. So really simple. If TU is 85, then ST must also be 85. You just have to be sure that this line shows that it's a perpendicular bisector. If it doesn't, then you cannot prove that those sides are congruent. Here's your question. If line segment QT is congruent to line segment ST and RS equals 56, what is QR? This question says, can you use the angle bisector theorem to solve for the measurement of FHG? Well, if I look at this, I've got two sides that are congruent, two right angles. When this looks like it was just unfolded, which would mean this line is also, it's the same line, so that means it's the same on both triangles. So yes, I could use this to find the measurement of FHG, and that would be 55 degrees. But notice I've got a lot of information here, and I have to have it before I can prove that those two angles are congruent. Your third practice problem says, can you use the perpendicular bisector theorem to solve for SV? That's this length right here. The last question asks, what is the value of P? Notice, line HJ is a perpendicular bisector. These two sides are equidistant from J. That means these two line segments are congruent. That means they're the same. So I will write them equal to each other. I take one side equals the other side. Now all I do is find the smaller number of p's, which is 1p. I'm going to subtract 1p from both sides, which gives me 2p equals 24. Divide both sides by 2. That gives me p equals 12. So right here I can put down that p equals 12. And I can check it by saying 3 times 12 is 36, and 12 plus 24 is 36. That makes them congruent. Here's your fourth practice problem. If UV and UX are equal 34, and UWV equals 5P, and UWX equals P plus 48, what is the value of P? Which means if W is the angle here, W is the angle here. Your job is to solve for the letter P. So one more time on the happy scale, where are you? I hope not at I don't get it. I sort of get it. I got this. That's where we want you to be. Minimum. Or are you so good you could teach this to somebody? And that's the end of this lesson. Goodbye.